And I'd like to give our additional, we have a couple of vendor panelists here in addition to our end user presenters. So I'll give them just a couple of minutes to give us a couple of, quick intro about who you are and where you're from. So Chris, I guess we'll start with you.
Sure. All right, that works. Hello, I am Chris Harlow. I'm the Product and Customer Service Manager for Bedrock Automation. My background has been in process automation and in a lot of oil and gas sectors, as well as food and beverage and water and wastewater. So I've kind of done it all with different automation systems over the past 10 years. And in the past 5 years, my focus has been on bringing those automation systems up to the security postures that we have in modern IT systems, but allowing us to do that in a way that we don't interfere with OT operations and that we don't cause any downtime, and also bring systems up in a way that existing maintenance people and existing customer bases can use, understand, and deploy without getting frustrated by complexities or other issues that we've seen with this IT-OT convergence.
Great. And our next panelist.
My name's Ronnie Bear. Yeah, you can hear. I'm an electrical engineer by trade. I've been doing that for 37 years. I'm a power engineer. Out of those 37 years, 30 of those years I worked at the National Security Agency. Out of those 30 years, 15 of those was facilities engineering. So I've designed substations from 115 kV down to 120 volts. Lightning protection, grounding, harmonic studies, you name it, I've done it. The other 15 years I worked in computer network operations, which means I worked on teams that exploited, attacked, and defended critical infrastructures in countries of interest to the U.S. government. I worked for Fortinet. The way I look at this landscape, we do water, wastewater, oil and gas, electric utilities, manufacturing, building automation systems, building management systems. They're just systems. And if you use the Purdue model, you can go ahead and describe that system based on what you have existing to the managers, to your engineers, to your technicians on that. As my colleague said, Chris, we work 24/7, 365. Safety is number one, operations number two. Never get those mixed up. That's the way it works. So whenever you're going to do these systems, I always tell people I'm not here to sell you anything. I am here to talk to you about your system. You are the subject matter expert of that system, you and your operating system vendor. So if someone comes in an OT environment and starts trying to sell you something, just show them the door, because they do not understand your system or how it operates. And that's what you need to understand to help them. Thank you.
Thanks. Yeah, good intro. So I will start with a question about IT-OT convergence, since that seems to be a big topic this week. And I think, Con, you mentioned it in your presentation on the building side. Would you like to share some of your thoughts on some of the challenges of IT-OT convergence? And I mentioned in my presentation that, when it comes to smart cities and infrastructure, a lot of the emphasis has been on the IT side, not the OT side. Can you give us a few comments about the challenges there, and maybe some elements of success, for getting the two domains to work together? And I'd like to hear from everybody on this, but we can start with Con.
Yeah, I think for me, I work in our corporate IT side. I think for OT, kind of naturally gravitates for our business because of the market that we're in. Since we own and operate our buildings, I think that the key part of managing them has been on the OT side of it, but there wasn't really an OT function within our company before until I think about last year. And I think that was probably like kind of the biggest challenge, was to kind of educate our executives about the importance of having that. Because there was a void when, anytime there's like a building engineer or some sort of property manager would request some sort of kind of building system to be connected to the internet, they would just we would just tell them to go and talk to your vendor and rely on that. So we didn't really have resources in place to kind of manage that before. So part of our kind of challenge was to make sure that we, hired at least one person to be able to solely be responsible for that function. And this is like the importance of why we need to have that in place. So now people have like a central authority to kind of come to and talk to you about it. And it's kind of, for me, I've expanded my role on like the corporate side to kind of expand more to the building side as well.
Good, good. Anyone else care to comment?
Sure, I'll actually hit on this from the other side, which is the OT side. One of the biggest issues that I've seen with IT-OT convergence is just lack of education on both sides about what the groups are doing. OT systems are generally very static, sometimes for years on end. Nothing's being added, nothing's being changed. It's just running its process over and over and over again. And it does that well, and it keeps the system up. IT is constantly changing. There's all new technologies coming out, and they have to stay ahead of, in the traditional Purdue model, IT has been in charge of security. So all of the changes have happened up here for security, and OT is just cycling around and doing its thing. And OT has always had this view that, when IT tries to come down to this level, we have downtime. And then we get blamed, and then, our process isn't there, it's not running, and revenue is lost, and all of a sudden there's all this, issues going on, or even safety complaints, because there's this fundamental view of, in OT, if it works, don't touch it. And in IT, if you don't touch it, it's gonna stop working, and it's gonna stop working really fast. So how do we bring those two concepts together where we need to do updates, we need to fix the OT level? How do we use all of these technologies and all of these strategies that IT has been developing for years and years, bring it down to the OT level? And the answer is education. Let's talk about what's going on at this OT level. Let's explain the process in IT terms, and then let's talk about what's going on with the IT concept and the security, and merge it with those OT concepts and those protocols. How do we get security through from layer 0 up to layer 3? We need to start way down at the bottom. Let's relook at everything right at the sensor level. Let's look at what the sensor's doing, what data it's generating, then move up to the PLC level, then the SCADA level, and then the MES level. And if we go from the bottom up, with IT and OT working together, everybody understands, and you build this whole roadmap going forward for how to make everything work. But nobody's really been doing it that way. It's always been, let's look at it from the top down and tunnel our way through, and all of a sudden things stop working at the bottom because we're affecting middle levels, and that just breaks the communication. So bottom up.
Yeah, I'm definitely with you there. Starting at level 0 is where you got to start. Shay, did you want to make a comment about that? I'm sure, did you have any of your own issues? Okay, how about Ron? You want to say a couple things?
The way I look at it, this is the way I explain it. You're running an IT hardware and IT software in an OT system. So you need IT as well as OT. I am running an OT operating system, software system on IT hardware, and I'm running OT protocols on IT telecommunications backbone. So as we were talking about malware specifically targeted for OT is for OT. Malware that's specifically targeted for IT is in your OT system also, because you're still running Windows NT, Windows 95, Windows 98. You are not done on malware. So you need to look at both, and that's where IT and OT converge. And that's where IT and OT personnel have to work together, because the IT personnel from Social Security is a teenager. IT cybersecurity personnel is a baby still crawling.
Good comment, good comment. Do we have any questions from the audience? I believe we have an ARC person with a microphone here that would be happy. Yes, Chris, right? We got a question right here.
Oh, hey, Jim, thanks. This is, to me, a really...
Just tell us who you are.
Okay,
real quick.
Chris Davis, VP
Okay.
of Smart Cities at Simcom. I thought Larry's introductory slides were quite telling, and I agree with you that the OT-IT codification, if you will, is really, a huge issue. And I think it's even more, I think it's a harder problem to solve. This is my opinion. I'd love the panel's opinion. When you look at what's being deployed outdoors to instrument those physical assets that are in cities, so you're putting sensors, they're talking to edge computing devices over various types of low-powered or mesh networks. And it's just it's a free-for-all, right? It's like going to a disco and you've got all these different characters out there. And I'm just terrified, since we're in this space, that there's not been enough attention given to how do I instrument or how do I protect a pressure sensor that's on a fire hydrant that's talking over Sigfox or LoRaWAN that's talking to some access point. So I just love the panel's opinion on this and what's to be done. How can we move forward and make these systems, which are mostly outdoors, more secure?
Good question. Anybody want to start?
Sure. In the simplest terms, data. Lots and lots of data. We're looking at, in your example, the pressure sensor on the fire hydrant. We should know from the point that was installed to right now all of the data that's put across. And assuming that the device doesn't have some advanced IT security options, encryption algorithms or authentication, they usually don't, and they should, but we'll get there eventually when, market acceptance. But at the higher levels, you do have that. So let's look at all of the data that's coming out of that, and we can trend it over time. In an OT world, generally speaking, as I said, things are static. We're not adding anything to that. We have this pressure sensor. It's putting out a pressure. Sometimes it goes low and we get alarms. Sometimes it goes high and we get alarms. But generally speaking, it's going to be in the middle there. And its network packet information is pretty static. So let's take anomaly detection and put it right at the next level. So sensor is level 0. Let's put it right in the PLC. Let's do anomaly detection on the PLC that's reading that sensor data, and we'll know immediately if all of a sudden the network profile of that changes. And
what you find in cities, my background is factory automation. So what you find in cities for a lot of the types of applications, traffic counting, people counting, air quality, there are no PLCs. These are all OT devices. So, the paradigm that works in the IT and the factory floor and process control world doesn't work.
Right.
And I think that the industry is struggling, and a lot more consideration needs to be given. So how do we advance the state of the art? And Larry, I want your slides, by the way. I sent you an email just a few minutes ago.
Oh, yeah, no problem.
So anyway.
I guess without a PLC, my answer remains the same: is bring that anomaly detection, bring the encryption and the authentication as close to the edge as possible. Bring security as close to the edge and do monitoring there as well as at the higher level. You don't need to store an entire lifetime of data right at the edge, but you should have a general profile as close to the edge as possible. And there are some technologies out there to do that.
Yeah, and then if you're thinking about control networks, right? A sensor in IoT impacts an OT system. It does not operate an OT system. So your operators will know, your engineers will know whether that system's running correctly or not by feel. So if I'm trying to spoof you at that sensor to either make you send less water or more water or pressure or reduce it, however, I know by the way my OT is operating whether that's good data or not, like Chris was saying. Data is the key in that. I need the data from there, but I need the data in the OT system. And I'm looking for them to match or match closely within a window of a percentage sign. So that's how you're going to do that. It would be great if these IoT Wild West people had some type of security in their sensors. They're not going to put it. It's too expensive as far as they say. IEEE did a study 2 years ago. It costs 75 cents to put security on an integrated circuit chip. 75 cents, people. That would solve tons of these problems. And you know what? That's too expensive.
Yeah, I've
So-
heard the same thing. It's too expensive.
This is never, that's why Bedrock's there, that's why Fortinet's there, Cisco. We're gonna be here a long time because the integrated circuit chip which to delaminate that chip is a nation state. They are the only people that can do that, would not spend 75 cents to protect us.
That's a great point and leads into my question. I'm Jim Frazier. I'm the Vice President of Smart Cities here at ARC. Today we've talked mostly about securing legacy systems. What I think Chris and I are concerned about is that as time goes on, we're going to have orders of magnitude greater things out there. We've got edge devices. Every light fixture is going to be a node. Every vehicle is going to be connected. And is there some structured, systematic approach that we can apply from either the NSA or the DOE or from, is there some more formal guidance that could help us along that path?
Go ahead, Chris.
I was going to say, you can pay standard. You can
Okay.
go first.
Nice segue into the standards discussion. Yeah,
Yeah.
I will follow up.
So from the standards, NIST is the federal government standards, right? So that's where you would go for that. But this Wild West stuff of that node being on the edge and being secure, or us telling people to do that, that's not going to happen. The government's not going to step in. We're going to let the commercial sector ride that one, depending on what they want to do.
I'm not necessarily asking for the government standards to jump in there, but is there, and I'm not a cybersecurity guy by any stretch of the imagination, but is there guidance like, do we need to secure each layer of the 7 OSI layers at each device, or things like that?
Right. I will tell you, because I don't know at this moment, NSA has two hats that they wear. They wear an offensive hat and they wear a defensive hat. So on their defensive hat, they will put recommendations on what you should do to secure your systems. Again, from the Fed side, but you can take that and use it in commercial. It doesn't matter, right? But they put those standards out there, published. We just don't go to this nth degree because we don't look at it as a problem. For us, the 16 critical infrastructures would support DOD or DOE or any of those. We'd look at water, wastewater. What are you doing? What is the electricity sector doing? What would be pharmaceuticals doing, right? Because of health and stuff. But they are not saying what to do as far as from a security point of view. They let the market take that.
Well, I mean, I do know, I'll answer a bit of my own question. I do know that in some jurisdictions here in the U.S., streetlights generate their own revenue grade actual bill per streetlight. Mm-hmm. And I'm not a security expert about that, but they're very careful about managing that actual, hey, how much energy did you use on that streetlight?
Yes.
I think Chris wants to comment on that.
Many streetlight controllers, it's a $100 device. They have a GPS and them so you know where the asset is. A revenue grade power meter to 0.5% accuracy. Mm-hmm. It just comes with them. A little bit of I/O, and of course a radio to talk over various, smart grid networks.
Yeah, the
Real-time
problem
clock,
with that is from an adversary, I swim upstream from that device, right? Because if you're not doing any security on it, that's my point of node to get in, and then I pivot when I get in. Mm-hmm. That's what I'm saying. These devices really, from an OT point of view, you really have to know your system inside and out to know that you're not being spoofed or whatever. My biggest thing on electric utilities is, with smart meters is, I either make you generate more than you need to generate, so I bankrupt you, or I make you generate less than what you need and I pop you off the grid. At least you live if I pop you off the grid. If I bankrupt you, that is not a good thing. And that's just one example. You can go through each critical infrastructure and do that. So these end devices not being protected are a huge liability for the grid, as well as for water and all the rest of the utilities that use these types of devices for metering and payment.
Anybody else care to comment?
Yeah, from a control and from a commercial perspective, at least, there were two questions, so I'm going to do them in reverse order. Is talking just about the street lights and how do you deal with the security at that level? It's first of all, we need to start thinking less and less about levels. This Purdue model is going to get flattened. It has to with this IIoT, as you're bringing more intelligence to the lower levels. You're not bringing it to the lower levels, you're bringing those lower levels up higher in the Purdue model. So at some point, it's going to flatten out, and then your entire security has to just be a ring around one level. And it's not just outside, it's in between as well. So I can't protect a streetlight if there's no intelligence in the streetlight, if there's no chip to do key management or, authentication and encryption. But what I can do is keep that light from infecting another light. So if you do get into one, you don't compromise the entire system. And this is what we're working with, Shay's group on at those levels. Those controllers and the edge nodes that they're controlling are all on one serial network. How do we segregate those so that if somebody has the crazy idea to drive out to this remote location and plug into one of those systems, they can't get on the entire network and then worm their way up from there. They only have access to what they have physical access to. And what it ends up doing is making it just too expensive to attack the system. You can't send a person to every streetlight to hack every streetlight. It just isn't reasonable. You'll find a different thing, or the adversaries will find a different thing to go after. So rolling that back towards the standards and the recommendation questions, there are groups and there are efforts that are in place. There's just last week, there was the Enhancing Control System Security by Creating Cross-Disciplinary National Accreditation and Certification Body. That's a really, really long sentence, and that was actually the title of the email. So you can imagine I got halfway through that and went, I forgot where this started. You probably have no idea what I just said. I had to read it off of here, and I've done this like 6 times now. But the idea behind that, in short, is get everybody together, start talking about this, figure out where we are, where we need to be, and how do we get there. And at the end, you'll have this cyber score that you can apply. You can look at your infrastructure, your building, your water utilities, and say, I've got a score of 7 out of 10 in this category. How do I get to 10? Or I've got a score of 1 out of 10 in this category. That's the low-hanging fruit. How do I fix that? Because you can't solve everything, and we shouldn't let perfection get in the way of progress. So let's look at where the worst parts are, and right now that's at the controller level.
And who's developing this scorecard? And how do
I
people
was
get
going to ask
involved?
that as well. Yeah, who's actually administering this body?
So that was a group that was a cross collaboration between ICS vendors, the DoD, and NEMA and ISA standards. Sorry? DHS. Yeah. So they were driving it, but the idea is that this body consists of vendors, standard-based systems, and the defense industry.
Let's expand on the standards discussion a little bit, and I'd like to hear from the end users here as far as there doesn't seem to me to be a lot of standards for cybersecurity that are related to smart cities and smart buildings and so forth. I mean, on the industrial side, we have IEC ISA 62443, which I understand is making some efforts to move into the area of building automation right now. I don't know if we have anybody from ISA that's prepared to talk about that here right now, but I'm wondering if the users could tell us, what do you look to, for cybersecurity standards, and what would you recommend, other end users, owner operators look to?
Well, typically, in our world, and the end users, you rely on somewhat your resources, which would be your engineering firms and/or AWWA to help you get in
Okay.
that same, level of security. So, as Chris was mentioning, the associations that might not be sort of impacting down to the level where you could be fined or something like that. In our wastewater industry, we have to, because they're telling us to monitor it at all costs. So when you go to these associations, and we've been talking about it locally at these forums, we've brought other municipality treatments, in our case, together as a team and say, how can you help us? And they've created what's called this guidance tool that you can go down to a level and say, hey, are you at this so-called score, so to speak? And
That's
so
AWWA that does that?
AWWA
Okay.
held it locally, and then they, asked for individuals to come in and sort of speak. But really, it was the local municipalities and water and wastewater people that said, let's share our knowledge inside the, room, and let's discuss how we get
Yeah.
from one stage to another.
I think I think I mentioned earlier in my presentation, for a lot of our buildings, they're LEED certified. And, being LEED certified, there's different levels of badges, I would say. There's silver, gold, platinum. Would like to see like a similar type of model being applied to the cybersecurity of our buildings front. With LEED certification, there's a benefit for that because it adds value to the building. Because if you're trying to sell the building later down the line, you get kind of a premium for that. And if we adopt some sort of standard, I think the challenge is always adoption of some sort of standard, kind of having some level of tiers. So eventually we can build in that value into like a smart building to say, hey, this building is a score of or a platinum level cybersecurity building, and that would kind of add value to that. But I think maybe that's where ISA or some of these other standard bodies would come in and kind of help establish that. But it kind of would take like a kind of a marketing effort for that, I would think.
Thanks. Do we have any other audience questions or comments?
Yeah, Larry, I'll continue on.
Sure. I got
know
more too. So.
NIST has a number of smart city super clusters, and I'm not intimately involved with them. I'm anecdotally involved. I believe one of them is cybersecurity related, and I believe they take the smart city model from the Smart Cities Council that defines 9 application areas. So there's wastewater, there's energy, there's the built environment for buildings, but there's another 6. I'm quite involved with the transportation cybersecurity task force that's doing much of the same work. And it's chaired by the head of the Institute of Transportation Engineers. The trade association is the Intelligent Transportation Systems Association. And most of the funding, of course, comes from the U.S. Department of Transportation. It would be a holy grail for all of us if those efforts, all of these efforts were harmonized into one cookbook that, hey, here's the right thing to do.
I totally agree. I don't know why we've got AWWA, NERC, EPA, DOT. These are all critical infrastructures. Why don't we have one cybersecurity standard, however you want to put it, to go ahead and do the cybersecurity for all of them? They're all system of systems. There are no two systems alike, but they all have end devices, sensors. If we're in manufacturing, wastewater, electricity, PLCs, RTUs, that's our world, that's the OT world. You'll never see that in IT. We all have some type of servers or laptops or some device that's going to come into that. They're all the same when you look at it, and the Purdue model kind of shows you that, right? Even though it's a layered model, it's, you've got end devices, you've got your PLCs, you've got wireless coming in, you've got this going to some server, you're going to go ahead and send some information to IT because all of that needs to be built. I don't know why. I know they had a risk management framework when I was there a few years ago before I retired. That was a beast.
You mean the NIST risk management framework?
Yeah, it was just atrocious. And we did it. We spent thousands of dollars with our own people, because we have over 150 facilities engineers at the agency, from civil engineers, structural engineers, electrical engineers, mechanical engineers, you name it. We build things out of the ground. There's nothing we can't do. We also manage our own EMCS and SCADA system. So this framework was just very, very hard.
It's still out there. In fact, we were supposed to have Keith Stouffer here from NIST,
that's
but
Keith's
that was
thing,
affected
yeah.
by the government shutdown, so they weren't able to make it
Yeah.
this week. Yeah.
So why we don't have that is beyond me.
Yeah, we should have one standard to rule them all,
Yeah,
but,
and why not under DHS, right? Because they're Homeland Security. They're in charge, to me, of all this critical infrastructure.
From your experience, my intuition says the IEEE might have an interest here. Do they?
They do, but it's only in the electronics part, right? Or it's only in the radio part, right? Because the IEEE is broken up into different entities, right? So
Right.
communications is this, utilities is that, and sensors are this. We need to have some type of holistic where it all comes together. My opinion is DHS because they do Homeland Security. If we could do that from Homeland Security, then you could then put that out to the
that would
world.
be NKIC then, I think, under
Yeah,
DHS, that would
We
administer
do,
that.
we do, at noon tomorrow, we do have an IEEE Smart City Planning and Technology Guide meeting.
Yeah.
I happen to be the vice chair. So maybe we're coalescing something here today to pull these
Yeah,
bodies
that
together.
sounds good.
Yeah, because we just have too many entities
Right.
for the 16 critical infrastructures, and they don't talk to one another. I've talked to water, wastewater people at the agency, they're EPA, they never talk to FERC, right? That's just not, it's too, but without electricity, water doesn't flow. Without water, right, we have problems with the dams, right, producing electricity. So they're all intermingled, intertwined, they're a system of systems.
So
Definitely a system of systems, I totally agree with you.
I do want to tack one thing onto there is one of the biggest reasons why there hasn't been this coalition around a cybersecurity standard is because up until very recently, the concept of automation was entirely proprietary. System A doesn't talk to System B. People running System A, water, wastewater standardized on a certain set of technologies that electrical completely different, oil and gas completely different. They're all working with different vendors. None of the vendors work together, talk together. None of their products work together, talk together. So we had to develop entire standards around each industry. And when cybersecurity came around, we were already too far down this path of we can't, this product has a different security model than this product. And this is used in water, this is used in oil and gas, so we don't have a single standard that could do cybersecurity for water and oil and gas. That's changing now. The convergence of open standards, and to be a little self-promoting, the idea behind open secure automation is get everything talking together. And once everything talks, you can create one security model to get it all talking securely, and then we can have one standard regardless of industry, regardless of technology. But it has to be, and there has to be pressure put on the vendors first to get everything working together, to abandon this proprietary model and the concept of security through obscurity and go with a open standard that we can all get working, and then we can secure that.
That's very interesting because the intelligent transportation systems world has gone down that path for a long time. And if you buy a traffic signal, it's completely interoperable. There is no ambiguity in the data table of objects, regardless of who you get it from. It's plug and play 100%.
And IT has gone this way. I'm sure that's true for building automation too, is, you get a mouse or a keyboard or a router or a switch, and it works regardless of who made your PC or who made the chips inside that, for the most part. Not 100%, and we'll not diminish the efforts of getting all that set up, but that hasn't been true in OT for the longest time.
I think that's kind of the idea between the Open Process Automation Forum here this week, right? Is we can all truly plug and play with formerly proprietary automation systems and so
Absolutely.
forth, yeah.
And we've been pushing that since we were created to do just that, is work across the board, so.
It's just gonna take us a long time.
Yeah,
Because we know our
yeah.
systems live 30 and 40 years. So, we'll have serial out there for a long time, and then eventually we'll get to IP. So the thing is, we gotta start now, so the new products that come out can be interoperable. And as we do the phasing of all the new systems with new products and stuff, then we're gonna get there.
And
It's
that's-
just gonna take us a long time.
And that is what Shea is doing, and that's one of the reasons why it's such a novel concept, and it's really great to work with Shea, is because they had that in mind. We're doing an upgrade now, let's look at where we need to be 30 years down the road, because this system is still going to be there 30 years down the road. How do we do that with both the technology and the security to get it all talking and interoperable, and work with the system that's been in place for the last 30 years? So now it's a 60-year gap that has to be considered. So that was a really great concept there.
Let's talk about trusted vendors for a minute. And I think, Con, you mentioned the concept of trusted vendors. You know, when I read about the Triton Trisis malware incident for process safety systems in the process industries, they talked about how, you know, one of the ways that attackers get into systems is to actually harvest credentials from trusted vendors, partners, and then move into the systems at the end user site that way. It's called island hopping, I believe. So what does it mean to you guys on the end user side to have a trusted vendor from a cybersecurity standpoint? You know, what is it that you look for in a trusted vendor? And then I would ask the vendors themselves, you know, what do you do to be a trusted vendor to ensure that, you know, there's no inadvertent cross sharing of credentials or information or anything like that?
I think for, you know, on the corporate IT side, we typically, when we procure like some sort of solution, you know, we usually request some sort of like SOC 1 or SSA 18. But in this space, you know, that's not really like a formal thing that has been really adopted. But, you know, there's similar type of like audit type of reports that we can request to kind of give some confidence in the event that there's some breach on their side. But you kind of have to do your due diligence, you know, making sure that, you know, hey, you say you do pen testing from this vendor, you know, can you provide us like that pen testing report that you guys do? So those are some of the things that, you know, we kind of adopt and look for in our trusted vendor.
Anyone else care to comment?
Yeah, I would say that that's pretty much ditto. One of the things, again, I'll go back to is the communication path that we rely on our resources that are out there. And again, in our industry, we're kind of dictated from the state requirements down to AWWA, and then that gets passed on forward. So we're relying actually on our vendors to stay up on that in our industry, just as much as our engineering firms.
So the way Fortinet, when they were started in 2000, they didn't do hardware, software. They built their system on an integrated circuit chip, and they have their own operating system. So as I said earlier, only way to delaminate that chip and find that is a nation state. So game on if they're after us. Really, that's the only thing I tell any customer or anyone that's looking at us in the Purdue model in the OT is that I have to understand your system, but you have to understand your system better than I do, because I'm going to give you different types of solutions. I'm going to give you suggestions, you know, do two-factor authentication, no more admin and password, or maybe three-factor authentication. Any one of your third-party vendors needs to come through you. You're the gatekeeper. We'll build the rules and make sure that we abide by them. But it's up to, again, the customer being the subject matter expert and their operating system vendor and all of the vendors underneath, because PLCs, they could have Rockwell Automation, they can have Siemens, ABB, Beckhoff, a ton of people down there. It's up to them to limit who comes in, how they get in, when they connect, who they connect. So I tell them three things. You need to have control of your system. You need to have the situational awareness of that system, the context of the information in that system, and you also need to have the visibility in the system. And that is OT visibility on all the OT protocols that you're running. So again, it's just a matter of here's an architecture you can use, but we're here to help you, but we are not your subject matter experts on your system. You are, your operators and your engineers. You know what's normal and you know what's abnormal.
And that's literally echoing that. It's a conversation, and it has to be an open dialogue, and there has to be transparency between vendor and end user. We have to, as vendors, explain what our system is capable of and what is out there and exactly how it works down to whatever the minute detail is required. And then we need to hear from the end users what they really need. we've kind of gone this opposite direction in OT since the late 90s, where it was, here's a new platform, here's what it does, make it work with your system. And here you go, end users, you're off and running with this. And they go, well, I need this. And it's, well, it doesn't do that, so you'll just have to work around it. Or they say, I need this, and it's, okay, here, buy this too. And then buy this, and then buy this. And one of the first points that was said was, if the solution is here, buy something else or buy this other product to go on top, especially around security, it's never going to work. We need to work directly with, and Shay has my cell phone number. You can call me up and say, I need to do this. And then I take that, bring it through R&D, develop a solution, test it, go back to him and say, is this what you need? Release it, and then he can implement it. And that's really where it needs to be driven from the customer service perspective. It's no mistake that my title is product and customer service manager, because that's really where it starts, with the customer service driving what the product's going to do. And we make it very transparent, so we have these conversations with what's needed and how to get there. We provide recommendations, but then we hear back, well, that's not going to work for us because we have X, Y, Z. We say, okay, that recommendation won't work. Let's find a middle ground. Let's work together there.
Good. Do we have any other audience questions here? No, I think probably getting pretty close to wrapping up here. We have a couple of minutes left. I have one more question, and that's about incident response plans, and I think at least one of you mentioned that. Would you care to talk a little bit about, why you should have an incident response plan, what goes into an incident response plan? Because this seems to be an issue with many owner-operators and users today. Things happen, you don't have an incident response plan in place.
Yeah.
Not a very good outcome, right? So.
Yeah, so I think for us, we probably implemented an incident response plans a few months ago. I think the purpose of an incident response plan is to know what to do in case something does happen. For us, some things we considered was, there's always these, I would say, events that could happen that aren't necessarily incidents. So we put together some parameters and guidelines as to, okay, when this type of event happens, these are the kind of the steps you take to kind of assess if this is actually an incident. And then the other part of it too, if you identify there is an incident, you kind of identify a few outside parties to know who to go to if there is an incident. Who the outside, let's say, law enforcement type of authorities are. Who, if you have cybersecurity insurance, like who your cybersecurity insurance providers are. And then, for us being publicly traded, we need to know what the protocol is to be able to communicate up the chain if something that is important enough to be reported on. So that way we're not kind of running around trying to figure out what to do next. We have an established set of steps to take in order for us to follow. And it's not just on the IT side, it's making sure that people in the field are aware that we have this plan in place, so if they do happen, they can report on it as well, not just rely on us to do that.
So there's, to go all the way back to standards from the beginning, there's ISO 9001 for developing policies and dealing with customers from a vendor perspective, and then ISO Secure Level 2 specifically talks about responding to cyber incidents and how you do those. And the general concept of both of those is build a policy that allows you to be proactive and reactive to issues, and make sure that that policy is flexible enough that you can adapt it to as many issues as you can imagine, and go through and list every issue you can imagine and see if the policy applies. It's a living document, that policy. It's not signed off once and then you're good to go. You revisit it at each incident to make sure that the policy was followed and that you met that. And then, once again, transparency. Hiding cyber events is the worst thing that can happen. Yes, it's embarrassing. Yes, it's going to cost money for publicly traded companies. Stocks will take a hit if they have a cyber event, but hiding it away, how many times have we seen it comes out 6 months or 9 months later that, oh, okay, Equifax, everybody's information was stolen, and it's, I could have personally been doing something about my information being stolen if there was transparency right from the get-go. If there isn't, then the whole thing falls apart. You can't just hide away and sweep it under the rug, because eventually that rug gets pulled up.
Absolutely. Okay, I think we're out of time. We have lunch coming up. I want to thank our speakers and our panelists here. I think you guys did a great job. I want to thank the questions from the audience. Let's give a round of applause to our speakers and our panelists here.